So continue on paragraph 4.6, and 4.6 is about additives. And that is basically something that we add to food, mostly. And they are supposed to improve. Sometimes they do. Sometimes they do, sometimes they don't. So they make it look better or taste better. E numbers is basically where you can recognize food on. It's E numbers. E numbers is European approval. And the European approval says that it's safe to eat. You prefer that. Some E numbers are weirder, like yellow dye has an E number, but citric acid has two. Citric acid obviously can just be found in lemons, for example. So not all E numbers are synthetic. Some of them are natural. Next to E numbers, there's also emulsifiers. You probably heard of emulsifiers before. They use it in biology too, and we also talked about it in chapter 2. It's a substance that makes two other liquids mix. And that is because they look like this. They have a hydrophobic tail. Hydrophilic head. There should be an A there. And that is what they that is how they mix up the mixtures. Okay. To make sure that the additives is not added too much of it, there's the MDI value. That is the maximum daily intake. So that is basically how much of a substance you can take daily before you actually suffer from health issues. So you will not necessarily die if you take too much of it, but you do have a risk of health issues. For example, the MDI value of vitamin C is 80 grams per kilogram body weight. So imagine a person that weighs 65 kilograms. How much vitamin C can he or she, whatever, take? 80 grams equals 1 kilogram. I have 65, so I make a ratio table. kilogram and body, and fit C in milligram. 1 kilogram is 80 grams. I weigh 65 grams, so 80 times 65 divided by 1. 8 times 6 is 48, 5 times 6 is, so this is 520 grams. This way you should be able to calculate with MDI value. Then, to continue on this, we have paper. Chromatography. And with that, basically you can separate stuff to investigate whether something is a pure substance or not. So this is basically separation method. What you actually do is you have a cup of water or any other solute. Example given, water or alcohol. And then you put filter paper in it, like this. And then you adjust some substance here. Mostly you just make some dots of coloring agent, for example. And then the liquid will move upwards into the paper. Then it will take this. So it depends on the solubility. If it is soluble, then it will go up, because this water will dissolve this, and then it will take it with it. Then there's another question: is there adhesion? Yes. In that case, it will stay. Adhesion to paper. Soluble in solute. This is the solute. If the adhesion to the paper is high, then it will stay. Because it loves the paper, so why on earth would it join this? So there is a ratio between them. If it is soluble and it's soluble in the solute and it adheres to the paper, then it has a problem, because it would like to go up and it will stay, so it will probably come halfway somewhere. Not all substances have the same solubility and the same adhesion. So that is why all the substances will end up somewhere else on this paper. We are going to do an experiment with this so that you can actually see that this is working. Eventually you'll end up with this piece of paper, and this is what we call a chromatogram.